Expanded flow. Expanded flow is an advanced topic, but mastering it is critical if you are designing large storage and feed systems handling difficult flowing materials, including big storage tall bins and below ground pile reclaim systems. It is not uncommon to find yourself in a situation where you are designing for a bulk solid that requires either steep hopper walls to achieve reliable mass flow or very large effective discharge outlets to achieve reliable funnel flow. In this situation, designing for either pure mass flow or pure funnel flow is impractical. The solution is to combine mass flow and funnel flow in what we call expanded flow. With expanded flow, our storage and feed system has two layers. The bottom layer empties in mass flow, while the top layer empties in funnel flow. The idea with expanded flow is that we use a short mass flow section to open up and create an effective discharge zone that is greater than the bulk solid's piping dimension. And as long as this large effective discharge zone is big enough, the bulk solid will reliably discharge in funnel flow. With expanded flow, we are taking advantage of one of the key characteristics of mass flow discharge. Remember the definition of mass flow. With mass flow, the entire mass of material in the storage bin comes down as a single body. All of the material in the storage bin is in motion, and that's the trick. With the stored material coming down as a single body, with all the material in motion, we have used our short mass flow section to flare out and create a big effective discharge zone for our funnel flow section. And when this effective discharge zone is bigger than the piping dimension, we get reliable funnel flow. The primary advantage of switching to funnel flow is that you don't need steep hopper walls. In fact, you don't need any walls. For example, reclaiming from underneath a pile. Or if you want, you can go with shallow hopper walls and pick up a lot of storage very quickly. The one caveat with expanded flow is that you must have true mass flow in the mass flow section to actually make it work. This means that not only does the geometry of the mass flow section need to be right, I'm talking about sufficiently steep hopper walls and a sufficiently large enough discharge opening to overcome the bulk solid's bridging dimension, but also the mass flow section's discharge opening must be fully effective. This means that the material is emptying evenly from the discharge outlet's full width and length, and this has everything to do with the behavior of the feeder. If the feeder were to instead pull material preferentially for one part of the discharge opening, you will get funnel flow in the mass flow segment. The result is a storage and feed system that will be susceptible to chronic rat holing and bridging. This is where a feeder that withdraws material evenly from a discharge opening's full width and length, such as the KamengoU feeder, is very helpful. Expanded flow is a very powerful tool when designing large storage applications handling difficult flowing materials. By combining a mass flow segment with a funnel flow segment, you get the best of both flow patterns to achieve designs that neither could effectively do alone. To learn more about why bins plug and the theory that underpins good bin and feeder design, visit the KamengoU website and download our white paper.